In this video, we will solve exercise of acids, bases and salts. Let's start the session. What is the first question which is given? The question is, write balanced chemical equations for the following neutralization reactions. Some neutralization reactions are given and we are asked to write the balanced chemical equation. Let's see what is the first reaction. The first reaction is reaction of sulfuric acid with magnesium hydroxide to form magnesium sulfate and water. Now we will write the balanced chemical equation for this reaction. Sulfuric acid, we know the formula for sulfuric acid is H2SO4. Sulfuric acid on reaction with magnesium hydroxide, MgOH whole twice, reacted to form magnesium sulfate, MgSO4 plus water. So this is the balanced chemical equation for the reaction between sulfuric acid and magnesium hydroxide to form magnesium sulfate and water. Let's see what next question is given. In the next question, we are asked to react sulfuric acid with sodium hydroxide to form sodium sulfate and water. Now we will write the balanced equation for this reaction. Sulfuric acid H2SO4, sodium hydroxide NaOH. After the reaction, we get sodium sulfate Na2SO4. Since in sodium sulfate we have two sodium atoms, so here we write 2 to balance the chemical equation, plus we get water H2O. To balance the number of hydrogen atoms, we write here 2. So this is the balanced chemical equation for the reaction between sulfuric acid and sodium hydroxide to form sodium sulfate and water. Now we will see the next chemical equation question which is given. In the next chemical question, chemical reaction, nitric acid on reaction with ammonium hydroxide will form ammonium nitrate and water. Now we will write the chemical reaction for this equation, word equation. Nitric acid HNO3, ammonium hydroxide NH4OH. This is ammonium hydroxide. When nitric acid reacts with ammonium hydroxide, we get ammonium nitrate NH4NO3, ammonium nitrate plus water H2O. So this is the balanced chemical equation between the reaction of nitric acid and ammonium hydroxide to form ammonium nitrate and water. Now we will see the next word equation which is given. In the next word equation, a reaction is given between carbonic acid and sodium hydroxide to form sodium carbonate and water. So we will write the balanced chemical equation for this reaction. Carbonic acid H2CO3 is carbonic acid, sodium hydroxide NaOH is sodium hydroxide. After the reaction, we get sodium carbonate Na2CO3. Since here we have 2 moles of sodium atoms, that's why to balance the chemical equation with the sodium hydroxide we will write 2, and as well as we get 2 moles of water, 2 moles of water molecule. So this is the balanced chemical equation. I hope this equation is clear to you. Now students, we will see the next word equation which is given. Next equation is the reaction between nitric acid and barium hydroxide to form barium nitrate and water. So we will write the balanced chemical equation for this word equation. Nitric acid HNO3 is nitric acid. barium nitrate, barium hydroxide, BaOH whole twice. This is barium hydroxide. After the reaction, we get barium nitrate, that is BaNO3 whole twice. Since here we have 2 moles of nitrate, so we must write here 2. Plus we get 2 moles of water. I hope this balance equation is clear to you. Now we will see what next word equation is given. In the next word equation, we have the reaction between hydrochloric acid and calcium hydroxide to form calcium chloride and water. Now we will write the balance equation for this word reaction. Hydrochloric acid, HCl, calcium hydroxide, CaOH whole twice. After the reaction, will form calcium chloride, CaCl2. Since here we write 2, so with HCl we will write 2 to balance the chemical equation, as well as we get 2 moles of water. I hope this is clear. Now we will see the next question. Now here in the next question, we are asked to identify Bronsted-Lowery acids or bases in the following reactions. Identify Bronsted-Lowery acids or bases in the following reactions. We know very well what are Bronsted-Lowery acids. Proton donors are Bronsted-Lowery acids, while proton acceptors are Bronsted-Lowery bases. Now we will apply the concept of Bronsted and Lowery for the following reactions to identify which species is Bronsted acid and which is Bronsted base. Now we'll start the question. The first reaction which is given is, it is a reaction of nitric acid with water to form hydronium ion as well as nitrate ion. Now in this reaction, here we will see nitric acid is proton donor. Nitric acid donated its proton to water. After donating proton to water, nitric acid changes to nitrate ion. Since nitric acid is proton donor, so that's why nitric acid is Bronsted acid. So it is Bronsted acid. H2O changes to H3O. H2O changes to H3O after accepting one proton from nitric acid. So that's why water is a Bronsted base. Since it is proton acceptor, so that's why water is Bronsted base. I hope this is clear. Now we will see the next question. In the next question, acetic acid and water, they are given, and we are asked to identify which is Bronsted acid and which is Bronsted base. Now here acetic acid donate protons to water. Acetic acid changes to acetate ion. Acetic acid changes to acetate ion after donating one proton to water. Since acetic acid changes to acetate ion after the donation of one proton to water, so that's why acetic acid is Bronsted acid. Water accept proton to acetic acid, and after accepting proton, H2O changes to H3O plus. Since water is proton acceptor, so that's why water is Bronsted base. It is Bronsted base. I hope this is clear. Now we will see the next question which is given. In the next question, we have reaction between ammonia and nitric acid. Here we can notice nitrogen of ammonia has lone pair of electron. So after nitrogen of nitric acid is proton donor, while ammonia is proton acceptor. Since nitric acid is proton donor, it donates its proton to ammonia, and ammonia is proton acceptor. That's why nitric acid is Bronsted acid, while ammonia is a Bronsted base, since it is proton acceptor. Now we will see the next question which is given. It is bicarbonate ion and water to form carbonate ion and hydronium ion. Now we will see in this reaction water changes to hydronium ion while bicarbonate changes to carbonate ion. Bicarbonate ion is proton donor. It donated its proton to water. Since it is proton donor, so that's why it is Bronsted acid. Bicarbonate ion is proton donor, that's why it is Bronsted acid. While water is proton acceptor, that's why it is Bronsted base. I hope this is clear. Now we'll see the next question. In the next question, ammonia and water reacted to form ammonium ion as well as hydroxide ion. In this reaction, water changes to hydroxide ion after donating one proton to ammonia. After accepting one proton from water, ammonia changes to ammonium ion. Since ammonia is proton acceptor, so that's why ammonia is Bronsted base. Water is proton donor, so that's why water is Bronsted acid. I hope this is clear. Now in the next reaction, here we can notice in this reaction HCl changes to chloride ion after donating its proton to bicarbonate ion. So HCl is proton donor, that's why HCl is Bronsted acid. Bicarbonate ion changes to carbonic acid H2CO3. Since it is proton acceptor, so that's why it is Bronsted base. I hope this is clear. Now in the next question, we have reaction of hydrogen sulfide ion with water. Hydrogen sulfide ion changes to sulfide ion after donating its proton to water, and water after accepting proton changes to hydronium ion. We know very well proton donors are Bronsted acids, so that's why hydrogen sulfide ion is Bronsted acid. Water is proton acceptor, that's why it is Bronsted base. I hope this is clear. Now we will see the next question which is given. In the next question, we are asked to identify Lewis acids and Lewis bases in the following reactions. Before going to identify Lewis acids and Lewis bases, we must know what are Lewis acids and what are Lewis bases. We know very well Lewis acids are electron pair acceptors, while Lewis bases are electron pair donor. Electron pair donors are Lewis bases, while electron pair acceptors are Lewis acids. Now we will identify which species is Lewis acid and which one is a Lewis base. The first question which is given is the reaction of fluoride ion with boron trifluoride.